Look at some graphs of functions. The graph of a function f of x is a set of points of the form x f of x. So I'm in the coordinate plane. The x-axis is given by x, and the y-axis is given by the values of the function at x. So there are some basic shapes of functions I'd like you to be familiar with. Here are some graphs of commonly seen functions. The first is a line. We've seen this earlier in our course. This is the equation for a line with slope m and y-intercept b. The graph is pretty simple. You can also graph powers of x. So here's the graph of x squared, the basic parabola shape. The graph of x cubed goes like this. And the graph of x to the fourth looks similar to a parabola, but is a little bit thinner. The graph of the square root function looks as shown. This is actually the graph of a parabola on its side cut in half. The domain of this function is all non-negative numbers, which is why there's no red line on this half of the coordinate plane. We can graph reciprocal functions. So here is the graph of 1 over x. The domain of this function is all numbers except for 0. So that's why there's no dot in red on the y-axis on this graph. Here's the graph of 1 over x squared and 1 over x cubed. We've seen the absolute value function before. That graph looks like a V. And then the last basic shape of a graph I'd like you to be familiar with is that of a half of a circle. This is half of a circle because if you say that this expression, the square root of a squared minus x squared is equal to y, and you square both sides, then you get a squared minus x squared is y squared, or a squared is y squared plus x squared, which we've seen in a previous video is the equation for a circle. You only get top half of the circle because you took the square root, and the square root of a number has to be positive. So here are some basic graphs of commonly seen functions. You can define other functions and graph them by plotting points. So here is an example. Let's graph the function f of x. Let's do a piecewise defined function. Let's say it's 2x plus 4 if x is less than negative 2. The absolute value of x if x is in between negative 2 and 2, and 1 over x if x is bigger than 2. So to graph this function, we can plot a bunch of points and try to understand what's going on. If I'm an x value that's less than negative 2, then I draw this graph of the line. So the line is a basic shape I showed you on the previous page. You could plot a couple points if you are not sure where the line is situated. But the line, I believe, goes something like this. So that's the part of the graph less than negative 2. If I'm in between negative 2 and positive 2, then I have the graph of the absolute value of x. So we know what that looks like. That looks like a V shape. Goes like this. And if I'm bigger than 2, I get the graph of the reciprocal function 1 over x. So the reciprocal function comes down like this and gets closer and closer to the x-axis. So there's x and there's f of x. So we can combine the basic shapes to define piecewise functions. Now, the key realization is that any graph of a function must pass the so-called vertical line test. Or VLT. What this means is if you drew the graph of a function, that function can only intersect any vertical line at most one time. So here is an arbitrary depiction of a function that has domain all numbers from A to B. If you look at any number at all on the real line, so if you pick a number x, there has to be a single height, a single f of x. If you go back to the definition of a function, it says that every x in the domain has a single f of x value, not two. There's a unique one. That means if you look at a vertical line, that vertical line must intersect the graph at most once. What would not pass the vertical line test is the following. So this is not the graph of a function. So I'll give you an example of something that fails the vertical line test. So this fails the vertical line test because if I pick a value of x under this loop type object, then there's not a single height f of x. There's not a single value. There's, in this case, it looks like 3 values. So this fails the vertical line test. Any graph of a function must pass the vertical line test, otherwise it wouldn't even be a function to begin with. Okay, wonderful.